AI has taken over the world. The Terminator knocks at your door. What do you say? Well, nothing, because you don't know how to speak the language of machines. So let me teach you how to speak to a robot and save your life. You see, machines have their own language based on binary. That just means that they use only zeros and ones. But why just zeros and ones? Well, because computers use electricity, and as it turns out, the most basic thing that electricity can do is be either off or on, 0 or 1. So the way to communicate is like flipping little switches on or off. We call one of these little switches a bit. Now let's say you have a group of 4 bits. Now you might be thinking, well, that's great, but that only allows us to count up to 4. Not so fast, because we'll be using base 2 numbers. And what that means is that the value of each of these bits, as read from right to left, doubles. So we have 1, 2, 4, and 8. Now every time we throw up one of those switches, we're basically saying, I want this value. If you want to tell the computer 2, then I throw up the switch for 2. If I also flip the switch for 1, then I get 3, 2 plus 1. So if you were to go up to a robot and say 0101, he'd understand you meant 5, and he'd probably reply,
Yes, I had 5 for breakfast. It was delicious.
Congratulations, you've just learned how to speak binary, the language of machines. It's all numbers, only numbers, nothing but numbers. If we throw all the switches on, then we get the number 15. And if we turn off all of our switches, then we get 0. So altogether we have 16 possible values from 4 simple bits. But all these bits get pretty hard to manage, so we usually have them in groups of 8, which we call a byte. You can think of bits like letters, while bytes are like words. Bits are usually shortened to lowercase, while bytes are uppercase. So when you see an image on your hard drive that's listed as 1 MB, capital B, then you know the image file contains 1,000 groups or bytes of 8 bits each. An 8-bit byte lets you have values from 1 to 128. If you flip the switch on all of them and add them together, you get 255. You therefore have 256 values because we have to remember to include the number 0. Well, that's not that much, so we use multiple bytes or groups of 8 bits together to give us access to larger numbers, kind of like using words to create sentences. So if we go up to 16 bits or 2 bytes, we get access to 65,536 values. But if we double that and go up to 32 bits or 4 bytes, we can reach numbers that are in the 4 billion range. Well, that's more than enough for most modern-day uses. But hey, wait a minute. You use words on your computer. You create images. You watch movies. How do you get from numbers to actual usable stuff? Well, it's all up to how the application you're using interprets those numbers. Let's take an example. Say you type "hey" in a chat box. On the back end, the computer just sees this as 3 numbers. The uppercase H is 72, the lowercase e is 101, and the lowercase y is 121. This gets converted to binary and sent to your friend's chat application. On the other side, the process is reversed, transforming it back into "hey." But if you take the same numbers and bring them into an image app like Photoshop, you'd probably get this color, because it would interpret 72, 101, and 121 as values for red, green, and blue. The point here is that it's all numbers, which then get interpreted by the application or the software. By the way, the reasons letters are assigned specific numbers like 72 for capital H and so on is because a long time ago, computer scientists decided on a standard called ASCII. Now these days, ASCII's more modern cousin, UTF-8, has taken its place, and it extends the original set to include more characters. And there you go. Now you know how to speak to a computer. When AI takes over the world and the Terminator comes a-knocking at your door, you can use binary to talk to him. And you'd probably want to say something like this, which just means,
I know, home. Leave a message after the beep. Beep.
I'll be back.